So this one on the board is a wee bit different, as in you've got the three things here, but you're going to work out everything the same way. So you're still going to do your ZR the way that you did your ZR before. You know that that's ZR is the same as your R, which is 56 ohms. And then you know that that in rectangular form is just 56, and in polar form 56 at angle of 0. I've left out the 56 plus G0 this time. I think that's kind of become kind of self-explanatory now. So 56 ohms or 56 at an angle of 0. Then the same way as you would have done the last time, for the inductor, your ZL is your XL, which is your 2 pi FL. So that's your 2 pi times the frequency of the supply, 50, times your L is 180 times 10 to the minus 3. So let's have a wee look at that. 2. So that gets to 4 significant figures again, 56.55 ohms. And then that value in rectangular is 0 plus J. And then in polar form, your angle's plus 90. So that would be that. And then for your capacitor, your impedance of your capacitor is your XC, your 1 over 2 pi FC. And just remember when you're putting in your calculator, if you're doing it all at the one time, bracket it up. Microfarads, so it's times 10 to the minus 6. Yeah. For this one here, you get the same as me. I'll check it. 2 times, let's see if we can see it. 180. Okay. Right, okay. So back to this calculation here. And from XC, I've got 50.53. So then that, as a polar number, 0 minus J, just going back to your rules, resistors are real, inductors are plus J's, capacitors are minus J's. Or if you want that in polar form, the angle is minus 90. Again, just from your rules. So resistors have got an angle of 0, inductors an angle of 90, capacitors an angle of minus 90. Then when you do your total, you're going to add these three impedances together. And because you're going to add them in rectangular form. So you add and subtract in rectangular form, you multiply and divide in polar. So your ZR in rectangular form is just 56. No J's. Your ZL in rectangular form, you just have to put that bit there. Don't need the 0. And for your ZC, again, you don't need the 0, just that bit there. And because it's adding a negative number, you could just put minus J. And then the same as you would in maths, you collect like terms. So there only is one real number, that's that 56, but then you've got a plus J and a minus J, so overall your J is going to be positive, and it's going to be positive, Let's have a look. 56.55 minus 50.53. So that gets you 6.02. You know it's positive because the plus j number is bigger than the minus j number. That's your total as a rectangular number, and you're also going to need that as a polar number. That gets you 56.32 and an angle of 6.136. And that would be your Z total. My pen's kind of a wee bit out there. You just go on and work out the current the same way as you did before. You just do I equals V over Z the same way as you have in the other examples. Again, if the angle's not given, you make the angle 0. And then subtract the angles. That's the way you do the current. The way you do the voltages is exactly the same. So I've not really got space for it here. So VR, you just do I times R. VL, I times XL. VC, I times XC. And then once you've done these, you convert these to rectangular and add them to get the supply. And that's what I would like you to do to finish off today. Work out your VR, your VL, your VC, convert them to rectangular, add them up, and make sure you get that supply.